Hello everyone, today we are going through graphical meaning of zeros of a quadratic polynomial. So in this video we will study how to find the zeros of a quadratic polynomial using the graph. We know that quadratic polynomial is of the form ax square plus bx plus c, right? Here a is not equal to 0. It's a polynomial of degree 2. Since it's a polynomial of degree 2, it has maximum 2 zeros. Okay, 2 zeros means 2 solutions to the equation ax square plus bx plus c is equal to 0. Right? 0 of a polynomial means it is a solution to the equation p of x is equal to 0. P of x is the polynomial, right? So here it has maximum 2 zeros. And we know that graph of quadratic polynomial or ax square plus bx plus c is a parabola, right? There are two cases. Either parabola open upwards or parabola open downwards. Okay, it depends on either a greater than 0 or a less than 0. If a greater than 0, then the parabola open upwards. If a less than 0, then parabola open downwards. Okay, note it down. And if the parabola touches at 2 points on x-axis, okay, if the parabola touches at 2 points on x-axis, then the polynomial has 2 zeros, okay. And if the parabola touches at exactly 1 point on x-axis, then the polynomial has only 1 zero, okay. And if the parabola does not intersect x-axis or does not touch the point on x-axis, then the polynomial has no zeros. See, here also no zero because this parabola does not intersect x-axis, right? So here this has no zeros. Next, let's go through some examples. Let's go through an example. Represent the quadratic polynomial x square minus 4x minus 5 on the graph paper and find the zeros. So here we have to draw the graph. To draw the graph, we have to plot the points, right? So here first of all, let's take y is equal to x square minus 4x minus 5. It is the given quadratic polynomial, okay? It is the equation, quadratic equation. And here, see, we have to substitute different values of x to find the corresponding value of y, right? To plot the points on the graph. So first of all, let's take one by one different values of x, okay? So it's better to take small values. So first of all, let's take x is equal to minus 2, okay? If x is equal to minus 2 square is 4. And 4 into, that is minus 2 square. So y is equal to minus 2 square 4. 4 minus 4 into minus 2, it will be plus 8, right? Minus 5, that is 12 minus 5, that is 7, right? So when x is equal to minus 2, y is 7. Next, put x is equal to minus 1. X is equal to minus 1. Y is equal to minus 1 square 1 minus 8 into minus 1 4 into minus 1 minus 4 minus minus become plus 4 minus 5. It is 0, right? Next is substitute x is equal to 0. Okay, minus 2 minus 1 0. 0, it will be y is equal to 5. Sorry, minus 5, right? Okay. After that, substitute x is equal to 1. Y is equal to 1 square 1 minus 4 minus 5. That is minus 9 plus 1 minus 8. Right? Next, substitute x is equal to, okay, when x is equal to 1, it is minus it. Substitute x is equal to 2, then y is equal to 2 square 4, 4 minus 8 minus 5. That is minus 9, right? 4 minus 8 minus 4 minus 4 minus 5 minus 9. Okay, now here let's plot the points. When x is equal to minus 2, y is 7. Y is 7. Okay. Minus values are here. So we have to represent minus values. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9. Okay. When x is equal to minus 2, y is equal to 7. Okay. So it is the point to minus 2, 7. Then when x is equal to minus 1, y is equal to 0. So it is the point. Okay. When x is equal to 0, y is equal to minus 5. So it is the point. It is the point 0 minus 5. Okay, x is equal to 0, y is equal to minus 5. Then when x is equal to 1, y is equal to minus 8. X is equal to 1, y is equal to minus 8. When x is equal to 2, y is equal to minus 9. Okay, so it is the point. Now let's try to join it. So here we will get. So some more points we have to find. Okay, it is not completed a parabola. So let's take some more points. So when x is equal to 3, so y is equal to 3 square 9, 9 minus 3 into 4 12 minus 5, that is equal to minus 3 minus 5 minus 8. Okay, minus 8. When x is equal to 4, y is equal to 4 square 16 minus 16 minus 5, that is minus 5. Okay, so minus 5. Now let's plot these points. When x is equal to 3, y is equal to minus 8. Okay, it is the point, right? Okay. Then when x is equal to 4, y is equal to minus 5. It is the point. Okay, now join this. After that, again when x is equal to 5, 5 square 25 minus 4 into 5 20 minus 5, that is 25 minus 25, 5 minus 5 0. So when x is equal to 5, y is 0. Okay. After that, when x is equal to 6, y is 6 square 36 minus 4 into 6 24 minus 5, that is 36 minus 24 8, 8 minus 5 3. So when x is equal to 6, y is 3. Okay, y is 3. So now we can stop it. Okay, now here we have got a parabola. That parabola touches at 2 points on x-axis. That is these 2 points, right? On x-axis. Parabola intersects x-axis at 2 points. That is, one is, it is the point minus 1 0 and it is the point 5 0. Okay, so here the zeros of the polynomial. What are the zeros of the quadratic polynomial? That is x coordinates of the points where graph intersects x-axis. Okay, zeros of the quadratic polynomial are x coordinates. Okay, x coordinates of the graph where it intersects x-axis. Okay, so here the points on x-axis, graph touches the points on x-axis are minus 1 0 and 5 0, right? Minus 1 0 and 5 0. Therefore, what are the x coordinates? Minus 1 and 5. So minus 1 and 5 are the zeros of the given quadratic polynomial. Okay, see, if you want, you can verify. Just substitute minus 1. Okay, you should get 0, right? Substitute minus 1. Minus 1 square is 1. 1 minus 1, see, when x is equal to minus 1, here we have already substituted, right? When x is equal to minus 1, y is 0, right? When x is equal to 5, y is 0. So here remember the zeros of the quadratic polynomial are the x coordinates of the points where the graph intersects x-axis. Okay. So here zeros of this given quadratic polynomial is are minus 1 and 5. Okay. Zeros of the x square minus 4x minus 5 are minus 1 and 5. Look at this question, very important question, CBSE 2010 question. In the given figure, the graph of a polynomial p of x is shown. Find the number of zeros of p of x. See here this graph is given. Okay, we have to find the number of zeros of p of x. See, it is clear that this graph intersects x-axis at only one point. That is this point, right? This graph touches at only one point on x-axis. Therefore, this polynomial p of x has only one zero, right? That is, p of x has only 1 0, right? Because this graph intersects x-axis at only one point. Therefore, how many zeros? Only 1 0. Represent the quadratic polynomial minus x square plus x plus 6 on the graph and also find the zeros of the polynomial. Here we have to find the zeros of the polynomial using graph. Okay. So here given polynomial is y is equal to minus x square plus x plus 6. So here we will substitute different values of x to find the corresponding values of y. So x, y. Now let's substitute x is equal to minus 3. So x is equal to minus 3, then what is y? Minus 3 minus of minus 3 square, that is minus 9. Okay. Plus minus 3 plus 6, that is minus 9 minus 3 minus 12 plus 6 minus 6 minus 6. When x is equal to minus 2, y is equal to minus of 4 minus 2 plus 6, 0, right? So when x is equal to minus 2, y is 0. When x is equal to minus 1 minus of 1 square 1, okay, minus 1 plus 6, that is 4. Y is equal to 4. And when x is equal to 0, y is equal to 6, right? Substitute x is equal to 0, you will get y is equal to 6. And when x is equal to 1, y is equal to minus of 1 square 1, so minus 1 plus 1 plus 6, that is 6. When x is equal to 1, y is equal to 6. When x is equal to 2, y is equal to minus 2 square, that is minus 4 plus 4, sorry 2, right? X is equal to 2, so plus 2 plus 6, that is 4. Okay. When x is equal to 3, y is equal to, substitute x is equal to 3, so minus 9 plus 3 plus 6, that is 0. Okay. Now here let's plot the points. See here we have got 2 zeros. Okay, now let's plot the points. So here when x is equal to minus 3, when x is equal to minus 3, y is equal to minus 6. Okay, we need minus 6 here. Okay, minus 3 minus 6. Okay, and when x is equal to minus 2, y is 0. So it is the point. Okay, it is the point 0 minus 2. Okay, it is the point when x is equal to 0, y is equal to minus 2. So it is the point. And minus 1, 4. When x is equal to minus 1, y is 4 plus 4. Okay, it is the point. Then when x is equal to 0, y is equal to 6. When x is equal to 0, y is equal to 6. It is the point. Okay. When x is equal to 1, y is equal to 6. When x is equal to 1, y is equal to plus 6. Okay. It is the point. When x is equal to, when x is equal to 1, y is equal to, when x is equal to 0, y is equal to 6. But when x is equal to 1, minus 1 square plus 1, that is cancelled, plus 6. Yes, 6, okay. Then when x is equal to 2, y is equal to 4. When x is equal to 3, y is equal to 0. It is the point. Okay. So here, let's try to join it. Here when x is equal to minus 2, 0. When x is equal to minus 2, y is 0. Here. Okay. So it is not the point. Okay. When x is equal to 0, when x is equal to minus 2, y is 0. It is the point. Okay. So here our parabola is okay, like this. So open this parabola, open downwards, because here our a is less than 0, right? See, minus 1. It is less than 0. Therefore, parabola open towards downwards. Okay. Therefore, here this parabola touches at 2 points. Right? This parabola touches at 2 points on x-axis. Okay, on x-axis. This parabola intersects x-axis at 2 points, that is minus 2, 0 and 3, 0. Okay. So what are the x coordinates? Minus 2 and 3. Minus 2 and 3. Okay. So here zeros of this polynomial are minus 2 and 3. Okay. X coordinates of the points where the graph intersects x-axis. So here x coordinates of the points are these 2 points, minus 2, 0, 3, 0. X coordinates of these points minus 2 and 3. Okay. Therefore, zeros of this given polynomial are minus 2 and 3. Next is a very important topic, relationship between zeros and coefficients of a polynomial. So first of all, let's consider linear polynomial. So linear polynomial p of x is equal to ax plus b. Right? Okay. And if k is a 0 of this linear polynomial ax plus b, then we can write p of k is equal to a k plus b is equal to 0. Why 0? Because k is a 0 of this polynomial. Okay. Then we can write, this implies k is equal to minus b by a. Right? Take this b here. So we will get ak is equal to minus b. That implies k is equal to minus b by a. So 0 of this linear polynomial is minus b by a. What is b here? B is nothing but constant term. Right? That is constant term. Minus of constant term. Okay? Minus b. So minus of constant term divided by what is a? A is the coefficient of x. Okay. So coefficient of x. So here we can say that 0 of a linear polynomial ax plus b is minus b by a, that is equal to minus constant term divided by coefficient of x. That is the relationship between 0 and coefficient of variables in linear polynomial. Okay. So that is, we can say 0 of, it is the 0 of this polynomial, right? 0 of a linear polynomial what is the 0? Minus b by a. Sorry, the linear polynomial ax plus b is minus b by a, that is equal to minus constant term divided by coefficient of x. Okay, it is the relationship between 0 and the coefficient of variables. Okay, that is 0 of a linear polynomial. Linear polynomial case, 0 of a linear polynomial ax plus b is minus b by a is equal to minus of constant term divided by coefficient of x. Next, for a quadratic polynomial, let's take general form of quadratic polynomial ax square plus bx plus c. Okay, here a is not equal to 0. Okay, then since it is a quadratic polynomial, it has maximum 2 zeros. Okay, so let's take alpha and beta are the zeros of this quadratic polynomial. Okay, that means alpha and beta are the solutions of the equation ax square plus bx plus c is equal to 0. Right? So here, since these are the solutions of this equation, or alpha and beta are the zeros of this quadratic polynomial, then x minus alpha and x minus beta are the factors of this polynomial. Right? See, these are the zeros, means these are the solutions of this equation. That is, x is equal to alpha and x is equal to beta. Means if you substitute alpha and beta in this equation, you should get this 0. Right? That is, x is equal to alpha and x is equal to beta are the solutions of this equation. So here that implies x minus alpha is equal to 0 and x minus beta is equal to 0. That means x minus alpha and x minus beta are the factors of this polynomial. So when you divide this polynomial by x minus alpha into x minus beta, you will get an integer as remainder. Okay, that is, this can be written as ax square plus bx plus c, that is equal to, these are the factors, so k into x minus alpha into x minus beta. When you divide this polynomial by these two factors, you will get a remainder, an integer. Okay, integer as remainder, that is, let it be k. Okay, then simplify this one. K into x, x square minus alpha x minus beta x. So take x outside, you will get minus of alpha plus beta into x. Okay, last term minus alpha into minus beta, that is minus alpha beta. Okay, then kx square minus k into alpha plus beta into x plus k into alpha beta. Now on comparing both sides, okay, coefficients of x square, coefficient of x and constant term, here we will get a is equal to k. Okay, a is equal to k. On comparing both sides, a is equal to k, then b is equal to, coefficient of x is here b, okay, here minus k into alpha plus beta. Okay, and c is equal to constant c, here constant k into alpha into beta. Then now what is b by a? B by a is equal to minus k into alpha plus beta divided by k. K is cancelled, that is minus alpha plus beta. Okay. Next, what is c by a? C by a is equal to k into alpha beta divided by a is k. K is cancelled, alpha into beta. Okay. Now here see b by a. What is b? B is the coefficient of x. Okay. Here for a quadratic polynomial, here b is coefficient of x. What is a? Coefficient of x square. So here what is the relationship between zeros and coefficient of variable or constant term? That is, here we can say that is coefficient of x divided by coefficient of x square. See, we can write alpha plus beta, take this minus here. So here we can write minus b by a. That is minus b, that is minus of coefficient of x divided by a is nothing but coefficient of x square. Coefficient of x square. It's very important, that is sum of zeros. Alpha and beta are the zeros of this polynomial, right? Therefore, alpha plus beta, that is sum of zeros, is equal to minus of coefficient of x divided by coefficient of x square. Next is alpha into beta, that is product of two zeros, is equal to c by a. What is c? C is the constant term, right? So c by a, that is constant term divided by a is nothing but coefficient of x square. Coefficient of x square. So sum of zeros is equal to minus coefficient of x divided by coefficient of x square, and product of zeros is equal to constant term divided by coefficient of x square. Look at this question. Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify relationship between the zeros and the coefficients. Here given quadratic polynomial is x square plus 7x plus 10. Okay, first of all we have to find the zeros. See here, you can, to find the zeros, here either you can apply quadratic equation that you will study in 4th chapter. Okay, so here we will apply this method, that is x square plus 7x can be written as 5x plus 2x, right, plus 10. That is, here see x is common, so let's take together these two terms. Okay, that is x into x plus 5. Okay, here take 5 outside, plus 5 into, take 5 is common in these two terms. Okay, take these two terms together, so take 2 outside, sorry, take 2 outside, so it will be x plus 5. So now in both the terms x plus 5 is common, right? So let's take x plus 5 outside, that is here remaining x plus 2, x plus 2. So this polynomial can be written as x plus 5 into x plus 2. That means 5 and 2. Minus 5 and minus 2 are the zeros of this polynomial. That is x plus 5 is equal to 0 and x plus 2 is equal to 0. That implies x is equal to minus 5 and x is equal to minus 2 are the zeros of this quadratic polynomial. Okay, and here, okay, we have found the zeros of this given polynomial. Now we have to verify a relationship between the zeros and the coefficients. Okay, so first zero, let's take alpha is equal to minus 5 and beta is equal to minus 2. Okay, now we know that alpha plus beta. What is alpha plus beta? That is minus 5 plus minus 2, that is minus 7. So minus 7 can be written as minus 7 divided by 1. Now here what is 7? See, 7 is nothing but coefficient of x. We know that sum of zeros is equal to minus of coefficient of x divided by coefficient of x square. Right? So here 7 is coefficient of x divided by 1 is coefficient of x square. Okay, it is verified, sum of zeros. Next, alpha into beta. Okay, that is product of two zeros. Alpha into beta is equal to minus 5 into minus 2, that is minus into minus plus, so 10. 10 can be written as 10 divided by 1. So what is 10 here? Constant term, right? So constant term divided by 1 is coefficient of x square. Coefficient of x square. Now it is verified. Look at this question, very important question. If alpha and beta are the zeros of the polynomial x square minus p into x plus 1 plus c, such that alpha plus 1 into beta plus 1 is equal to 0, then find the value of c. Okay. See here, first of all, here we have to apply the relationship between zeros and the coefficients. Okay. So first of all, let's write what is the relationship. It is given that alpha and beta are the zeros, right? So we know that sum of zeros, that is alpha plus beta, is equal to minus of coefficient of x. Okay. So here we will find the coefficient of x. See, first of all, let's write the equation polynomial x square minus p into x plus 1 plus c, right? That is my x square minus px, okay, minus p plus c, okay. Now coefficient of x is minus p and it is the constant minus p plus c, okay. That is our polynomial is x square minus px plus minus p plus c, okay. Now let's find alpha plus beta. Alpha plus beta is minus coefficient of x divided by coefficient of x square, right? That is minus coefficient of x is minus p, so it is minus into minus plus, right? So p divided by coefficient of x square is 1, that is p. Okay, now we have got alpha plus beta is equal to p. After that, alpha into beta, that is product of two zeros. It is given alpha and beta are the zeros, okay. So alpha into beta is equal to constant term divided by coefficient of x square, right? That is, what is the constant term here? Minus p plus c divided by 1, that is minus p plus c. Now see, one more thing, it is given alpha plus 1 into beta plus 1 is equal to 0. Let's simplify this equation. Alpha plus 1 into beta plus 1 is equal to 0. That implies alpha into beta plus alpha into 1 plus beta into 1, that is alpha plus beta plus 1 into 1 is equal to 0. See here, now here let's substitute what is alpha plus alpha beta, alpha plus beta. Alpha into beta is minus p plus c, okay. Alpha plus beta is plus p plus 1 is equal to 0. That implies here c minus p plus p cancelled, c plus 1 is equal to 0. C plus 1 is equal to 0. That implies c is equal to minus 1. See, we have got the value of c. C is equal to minus 1.